Hello everyone, welcome to PW. Good evening everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Great. So now we are on digital electronics lecture number 7, and till now we have completed multiplexers, and hoping all of you can solve any question based on the multiplexer now. Just by having last 2 hours of questions yesterday, you can solve any question. It doesn't matter whether it is asked in IAS, Indian Engineering Services, or your GATE, any PSU, anywhere. All questions you can easily solve if you have watched the yesterday lecture. Great. Good evening, Betaji. So today I am moving towards the next part, that is lecture number 7, and in this I am going to discuss about demultiplexer. Till now we have completed multiplexer. We will do some small part of the questions in this session as well, and then I will move towards the we will do some questions of multiplexers and also move towards the demultiplexer. Demultiplexer, decoder and encoder. I will try to start encoder by today. Okay. So please let me know by writing in the comment section, Betaji, whether audio and video everything is perfect. Can we go ahead? Great. Let's start with a question based on the multiplexer. Yesterday we have completed multiplexer, and I have also shown you how to solve different types of questions based on the multiplexer. Now you can easily do. But there is one question which is a delay based question, a specific kind of questions. Mostly these kind of questions are in GATE, but nowadays even PSUs, there is a lot of chances that they are in engineering services or PSU exam as well. Okay. So now please observe this question, one of the very, you can say, conceptual question from multiplexer topic. The GATE PYQ only. Let's have a discussion from this. So for the circuit shown in the figure, the delay for the NOR gate, multiplexers and inverters are 2 nanosecond, 1.9 nanosecond and 1.1 nanosecond respectively. If all the inputs P, Q, R, S, T are applied at the same time instant, the maximum propagation delay in nanosecond of the circuit is. You have to identify the maximum delay in nanosecond. Is it okay? All the inputs are applied at the same time. All the inputs are going to be applied at the same time. So we have a NOR gate, we have a NOT gate, that is an inverter. NOR gate will have a delay of 2 nanosecond. Multiplexer will have a delay of 1.9 nanosecond, and inverter will have a delay of 1.1 nanosecond. NOR gates will have a delay of 2 nanosecond. Is it okay? Yes, sir. It's a NAT type, so please try to answer in the comment section. Please try to answer this in the comment section. Okay, great. Hoping all of you have gone through the question now. Yes, sir. Let's have a discussion to this question. Please observe, please observe. I need this circuit to explain you. So allow me to take this circuit first. Hoping all of you can see this circuit. Great. Now please observe, we have to identify the minimum delay. We have to identify the minimum delay in the circuit. We have to identify the minimum delay in the circuit. For the circuit shown in the figure, the delay of NOR gate, multiplexer, inverters are 2, 1.9 and 1.1 nanoseconds respectively. If all P, Q, R, S, T are applied at the same instant, the maximum propagation delay in nanoseconds will be. So please observe here, what are the possibility for a select line to operate? If you observe, we have two possibilities. So I am representing in the two different cases. So let us suppose this is your case 1. Okay. Now please observe, everyone please observe, very important. Case 1, suppose if T is equals to 0, because there is only two possibility for an input T. Is it okay? Yes sir, we have to identify the maximum delay. So first of all, consider T is equals to 0. If T is equals to 0, is it okay? Yes sir. If T is equals to 0, then if this is 0, then it will select this I0 pin. And in order to have the input to I0 pin to be transferred to output, how much delay is required? Sir, this NOR gate delay is compulsory required. Is it okay? Yes sir. NOR gate delay is compulsory required, that is of 2 nanoseconds. So post 2 nanosecond only, if T is equals to 0, then post 2 nanoseconds only, input to I0 pin of the multiplexer will be valid input available. And then this multiplexer will further take 1.9 nanosecond time to have its output. It means the output of multiplexer 1 is available after 3.9 nanosecond. Is it okay? Yes sir. Since there is one inverter and the time taken by the inverter is 1.1 nanosecond, so this inverter will take 1.1 nanosecond, but this 1.1 nanosecond is within this 3.9 nanosecond. So we need not to consider this 1.1 nanosecond again. Is it okay? Because the inverter delay time is much lower comparative to the NOR gate and multiplexer delay. So if you are waiting for 3.9 nanosecond, automatically this inverter output is also available. Since the inverter output is logic level 1, so this multiplexer 2 is going to select I1 pin, and the information here, valid information, is available post 3.9 nanosecond. Again, this multiplexer will take 1.9 nanoseconds to provide its output. So how much time delay required for the valid output? So time required for circuit to operate properly is equals to, sir, 2 nanosecond of the NOR gate. Yes sir. Then we need 1.9 nanosecond of multiplexer 1, and then 1.9 nanosecond of the multiplexer 2. So can you please tell me how much minimum time delay required in case if T is equals to 0? How much minimum time delay required in case if T is equals to 0? Again observe case 2, if T is equals to 1, there is only two possibility for T, and T is onto the select line, so I am considering the select line because then only we can decide which input is needed. If T is equals to 1, then they haven't given any information about PQRST, just saying that all the inputs are applied at the same time. So there is a possibility that T is equals to 0 applied or T is equals to 1 applied. In case if T is equals to 1, then it means this multiplexer is going to select this I1 pin, and how much time this I1 pin, how much time needed for the correct input to the I1 pin, this 1.1 nanosecond is needed post all the inputs are applied. So post 1.1 nanosecond I1 pin input is available, then this multiplexer will further take 1.9 nanosecond to provide its output. Is it okay? Since this is the 1, so its complement is 0. When its complement is 0, so we have a NOR gate. We don't know about P. P can be anything. So it means the multiplexer output will also have a role. Is it okay? Yes, sir. In case if P is 1, then multiplexer output will have no role. We can start from here only. But since we don't know about P, is it okay? So the logic of P is not given. So we must know about both the inputs. We need to wait for both the inputs. Is it okay? Now, after 1.1 and 1.9 nanosecond, it means 3 nanoseconds, we have input available, both the inputs available to this NOR gate, and within this 3 nanosecond, this NOT gate will also operate. So we need not to consider the delay of this NOT gate. Now, how much time it is going to take? Further, it would take 2 nanosecond time to have its output. Is it okay? So 3 plus 2, 5, and then we have 1.9 nanoseconds more. How many of you able to understand, beta ji? Some of you are saying, sir, we need 5.8 nanosecond, 3.8 nanosecond. Please observe. Beta ji, can you please tell me how much time is needed? 1.9, 1.9 and 2. So 5.8 nanosecond is this. The minimum time delay in case if t is equals to 0, then 5.8 nanosecond. But what we are getting here, what is the time delay required here? Time required to operate circuit satisfactorily is, sir, first of all we need this time, so it needs 1.1 nanosecond of the inverter, then 1.9 nanosecond, then we need 2 nanosecond, and then we need 1.9 nanosecond. How many of you now able to understand, beta ji? So what is the worst case delay? What is the worst case delay? 1.1, 1.9 plus of 2 plus of 1.9. So worst case delay will become 6.9 nanosecond. Is it okay? So t can be 0 or 1. We have to consider the larger one. Why? Because they have asked you what is the minimum delay required for the circuit to operate satisfactorily. We don't know about the inputs. So inputs can be anything. So we will consider the worst case delay in this particular condition. So in case if t is equals to 1 possible, then maximum delay will be 6.9 nanosecond. So you can say the worst case delay minimum, or you can say maximum propagation delay of the circuit required will be equals to 6.9. Is it okay? In case if they have given the inputs, like if they give p is equals to 0, then the delay will be different. In case if they give you t is equals to 0, then the delay will be different, because if any circuit input we know, then we have to calculate accordingly. How many of you able to understand this question perfectly? Please let me know by writing in the comment section, beta ji. Please let me know by writing in the comment section. How many of you able to understand this question perfectly? Can you please let me know? Okay, I'm going to change this question a little bit and ask you once again. Please let me know how many of you able to understand now. I'm just going to change the question little bit, okay? Now please observe, keeping rest of the things same, even the circuit I am keeping the same. Even the circuit I am keeping the same so that it will take less time for you to analyze. Please observe here. If all the inputs P, Q, R, S, T are applied at the same instant, the maximum propagation delay in nanoseconds of the circuit is where T is equals to 1 and P is equals to 0. T is equals to 1 and P is equals to 0. Fixed logic. So if P is equals to 0 is fixed and T is equals to 1 is fixed, what is the maximum delay now? See, P is equals to 0, P is equals to 1. Let me take it as P is equals to 1, okay? P is equals to 1. P is equals to 1 and T is equals to 1. Now please observe. So if T is equals to 1 and P is equals to 1, then you have to find the maximum delay in this circuit. If P is equals to 1, then what happened? If P is equals to 1, this gate get disabled. And disabled means after 2 nanosecond, post applying P is equals to 1, after 2 nanosecond, its output will going to be equals to 0 only. How many of you able to understand? Yes, sir. It means its output will become 0 post 2 nanosecond. We don't know what is the status before 2 nanosecond, because we don't know about the initial values of PQRST. Is it okay? So, but at time t is equals to 0, at time t is equals to 0 means when all the inputs are changed. Is it okay? All the inputs are applied. When all the inputs are applied, if the initial state is not given, and they are saying when all the inputs are applied, so it will take 2 nanosecond to get the output 0, and then we have this t already 1.1 nanosecond is within this 2 nanosecond. So this will take 1.9 nanosecond. Total it will become 1.9 plus of 1.9 plus of 2 nanosecond. Is it okay? So this is the time required. Time delay required will become 3.9. How many of you now able to understand, Betaji? Because it has nothing to do with this circuit. In this case, this gate already get disabled with the one input fixed as 1. So it doesn't matter what the input come to the other terminal. How many of you now able to understand, Betaji? It's one of the greatest question. Hoping all of you able to understand this question perfectly. Great. Now let's move to the next topic. Multiplexer is clear to everyone? This is the extreme end what can be designed in the multiplexer. So hoping multiplexer is clear to everyone. Now let's talk about demultiplexer. So please write down DMUX, demultiplexer. Great, Betaji. Now please write down Thakur. Very good. Someone is asking, sir, Hindi thoda. Betaji, because this channel is a gate wala English channel, and this curriculum is going in English only, but I would try to keep the language as easy as possible. Is it okay? So if you just listen to me now, this is you can't say this to be a specifically a different kind of language. It's very easy for you. Okay, you can easily understand this language. Okay, I try to keep as easy as possible. Now please observe here, demultiplexer. It is just opposite to the multiplexer. What is the role of multiplexer? Multiplexer will have many input and one output. Like in our television, if many signals are coming, only one is displayed over the display unit. Is it okay? Based upon your channel selection. So multiplexer will work like that. Multiple input, single output. One of the input is transferred to output depending upon select or control line. Demultiplexer is just opposite to this. In demultiplexer, we have one input and multiple output. Input is transferred to one of the output line depending upon select or control. So this is also called as one-to-many circuit, one-to-many circuit or data distributor. Is it okay? Because the one data is going to distribute onto the desired output pin. So now please write down. It is a combinational logic circuit designed to switch one common input line to one of the several separate output line. One input line is switched to one of the several output lines. Depending upon control or select, input is transferred to one of the output. Input is transferred to one of the output, also called as one-to-many circuit. Sir, I am seeing all the lectures of the series in the recorded. Today I am watching live. Great, Thakur, great. So hoping you are able to understand the things and you are enjoying the lectures as well. Gaining as much as possible. Huh? Great. Next, write down. It can be used as a serial to parallel converter. It can be used as a serial to parallel converter. Next, it has 2 to the power n input lines and n select line. It has 2 to the power, it has only one input line. I'm sorry for this, there is a misprint. It has one input line. It has one input line, n select lines, and 2 to the power n output lines. 2 to the power n output lines. So please correct it. It has one input line, n select line, 2 to the power n output line. Size of demux is defined as 1 cross 2 to the power n, where n is the number of select lines. Is it okay? Yes, sir. Great. Let's try to understand the smallest size of the demultiplexer. Okay. Suppose we have 1 cross 2 demux. What does it means? It means one input line, two output line, and one select line. So the size of multiplexer is 1 to the power 1, where this 1 indicates select line, this 1 indicate input line, and this 2 indicate output line y0, y1. By default, output lines are top to bottom, LSB to MSB. However, in case if the internally this square box will have y0, y1 showing differently, we have to follow that. Is it okay? Because only designer knows which one is a LSB pin and which one is a MSB pin. By default, top to bottom, LSB to MSB. In case if it is not given, you have to consider top to bottom, LSB to MSB. Is it okay? Great, sir. In order to understand the functioning of the demultiplexer, we need to understand its switching circuit as well. So let's talk about switching circuit. Okay. Yes, sir. If we talk about switching circuit, it can be represented in this way. So we have a string and a spring. You can understand we have a switch here, y0, y1 as an output pin, and this is a switch. This switch can be controlled through a string. Whenever I am saying that the input S0 is equals to 0, it means I am not applying any force on this. Automatically it will be connected with y0. Whatever input is given, that is transferred to y0. If I am not applying anything, S0 is equals to 0, the information is transferred to y0. Or if I am applying force on this string, then the switch is connected with y1. Whatever information is given to input I, that is going to transfer to output y. So demultiplexer work as a data distributor. In this, input is being distributed in the number of output depending upon select or control. Is it okay? Great, sir. In order to design any desired combinational circuit, first of all, we need to identify the input output, understand the relation between the input output. Accordingly, we can construct truth table. So we have a input y, we have a input s select line and output y0, y1. So we have y1, y0. How many possibility with the one select? We have only two possibility with the one select. That is either the select is 0 or the select is 1. So if select is 0, what happened? Sir, input I is transferred to y0. And what happened to y1? It will remain low. If we are choosing select S0 is equals to 1, information I is transferred to output y1 and output y0 will remain 0. From this truth table, we can write logical expression for y0 and y1. What is the logical expression for y0? Logical expression for y0. Please observe, Betaji. We will get S0 complement I, and y1 we are getting S0 I. How many of you able to understand this? Great. Can you construct the Circuit, yes sir. To design any combinational circuit, first of all, we need to identify the input output, understand the input output relationship, accordingly construct truth table, write logical expression, minimize it, and then implement the logic circuit. So let's implement the logic circuit now. So we have a logic circuit having two AND gates, Y0 and Y1. We have two AND gate. One is giving Y0 and one is giving Y1. One input I, and we have a select S0 complement S0. So how many of you able to understand the internal circuitry of a demultiplexer now? So this is what we called 1x2 demux. How many of you able to understand the internal circuitry of the demultiplexer now? Is it okay, beta ji? Great, sir. If you observe, demultiplexer contains AND gate. It is similar to the decoder. The circuit of demultiplexer and decoder is almost, you can say, exactly same. Demultiplexer and decoder will have exact same circuit, but they are operating in a different way. We will talk about that. How many of you able to understand this 1x2 demux? How many of you able to understand this 1x2 demux? Let's have one question. Find the output, find the output Y for circuit find the output Y from the circuit shown below. Okay, suppose if we have 1, 2, 3. I'm sorry, beta ji. I just wanted to make a demux and made a mux. So allow me to modify it. Can you tell me what is the output Y from the demux and mux combination shown below? Can you tell me what is the output Y from the mux and demux combination shown in the shown below? Sir, we all can see we have a demultiplexer. These kind of things are mostly used in digital lockers. Okay. So if we have S0 is equals to 1, this A is being transferred here and this will become 0. In the same way, if this is 0, then B is transferred here and this will become 0. How many of you able to understand? Inside the demultiplexer, this 0 and 1 indicate Y0, Y1. Inside the demultiplexer, this 0 and 1 indicate Y0, Y1. In the same way, inside the multiplexer, these are representing I0, I1, I2 and I3. How many of you able to understand? Great, sir. Now demultiplexer is a usual representation as a standard representation, but the multiplexer will have different kind of representation. And for that, what is 1 0? For this 2 is going to be selected. So if you observe 0 1 2, y is equals to a in this circuit. Why? Because sir, we will get here because of the select line action. Because of the select line action, we will get here S2 bar S1 bar. We will get S2 bar S1, and we will get S1 S2 bar and S1 S2. So it can be clearly observed onto the S1 we have 0. So if we have S1 0, this will be 0, this will be 0. S2 S2 S1 bar S2 S1. Okay, so if S1 is 0, then this is 0, this is 0, and this S2 is 1, so its complement is 0. So all these three are going to be 0 only. Only for this we are getting S2 to be 1, S1 0, so its complement is 1, and A, so we will get A as the output from the circuit shown in figure. How many of you able to understand, beta ji? How many of you able to understand this demultiplexer as well? Let's have a discussion. Let's have a discussion of demultiplexer, little bit of higher size. So let's have a discussion of 1 cross 4 demux. If you want to design a 1 cross 4 demux, then how many number of inputs are there? Only 1. And how many number of outputs are there? 4. Y0, Y1, Y2, Y3. How many number of select line? Sir, we have 1 cross 4 demux can be represented as 1 cross 2 to the power 2. So we have 2 select line. It is in power. Is it okay? So you can say S0, S1. And we have a I. How many of you able to understand, beta ji? Please let me know by writing in the comment section. Now all of you can see whatever information we are going to give on the I input, that is going to be transferred to one of the output line. And we can easily think that if we are going to apply the binary of 0, information at I is going to be transferred to Y0 pin. For binary of 1, information is transferred to Y1 pin. For binary of 2, information is transferred to Y2 pin. And for binary of 3, information is transferred to Y3 pin. Now, once we know about the inputs and outputs, we can construct truth table. So if we talk about truth table, then we have a select line condition S1, S0, and output we have Y3, Y2, Y1, Y0. Please observe, beta ji. Sir, with the 2 select line, we have total 4 possibility, and you want input to be transferred to one of the output depending upon the select line. So we have either both low, any one of them is high, or both are high. If we talk about 0, 0, then definitely I0, I you want to be transferred to the output Y0. At that time, all the other outputs are 0. In the same way, for 0, 1, you want information given at the input is transferred to Y1 pin. In the same way, you want, sir, information transfer to Y0, Y2 pin, and information I is transferred to I3 pin. So now from the truth table, we can write logical expression of all the output functions. So we have output Y0 as S1 complement S0 complement I. We have Y1 as S1 complement S0 I, and Y2 S1 S0 complement I, and Y3 S1 S0 I. How many of you now able to understand? Please let me know by writing in the comment section, beta ji. Great. So from these output equations, can we have a logic circuit of the 1 cross 4 demultiplexer? Yes, sir. So if we talk about logic circuit of 1 cross 4 demultiplexer, it can be clearly observed. One input pin is connected to all, and depending upon the select line condition, input is transferred to the output. So as per the expression, we have 4 AND gate for Y0, Y1, Y2, and Y3. So I'm just drawing 4 AND gate. Then we need input select S0 and S1, and we also need S0 complement and S1 complement. So please observe. So we have S0 and S1 pin, and using one more pin, that is I, which is connected to each of the AND gate. How many of you able to understand? Only the dotted portion is representing there is an electrical connection. Okay, rest are like this. Okay, yes sir. Now if you talk about Y0, then we have Y0 S0 complement, S1 complement, S0 complement, S1 complement, S0, S1, S0 complement, S1, S0. So please observe everyone, hoping all of you able to understand up to this part. Okay. S1 complement S1, S2, S1 complement S2, S1. Now please observe beta ji and let me know by writing in the comment section if there is any doubt in this. How many of you able to understand this part perfectly? So is Y0, Y1, Y2 and Y3. We have our output Y0, Y1, Y2 and Y3. So now all of you can see a 4 cross 1 size. All of you can see a 4 cross 1 size demultiplexer. 1 cross 4 size demux. 1 cross 4 size demux. Beta ji, please let me know by writing in the comment section. If there is any doubt, please let me know by writing in the comment section. Can you design a 1 cross 8 size demux? Yes, sir. Can you design 1 cross 16 size demux? Yes, sir. Can you design 1 cross 64 size demux? Yes, sir. We can see 64 number of AND gates are there. How many of you able to understand, beta ji? Yes, sir. But when we discuss what size we want to design, okay, suppose if we want to design, we have to perform an operation of 1 cross 64 operation, but we have only availability of 1 cross 8 demultiplexer. Suppose we have to implement 1 cross 4 demultiplexer operation, but we have only available 1 cross 2 demultiplexer. Then how we can implement a higher order demultiplexer by using lower order demultiplexer? So let's have a discussion on implementation of higher order demultiplexer by using lower order demultiplexer. Please observe beta ji. Implementation of higher order demux by using lower order demux. Let us have one question. Calculate calculate and implement number of 1 cross 2 demux required to implement 1 cross 4 demux. Let us take the smallest size first. So I am considering 1 cross 4 demux. Okay. 1 cross 2. How many number of 1 cross 2 is required to implement 1 cross 4? Now please observe, just like a multiplexer, we can use this. So we want to implement 1 cross 4 by using 1 cross 2. Now the right side number is a higher number. You have to do the division. So this 4 will be divided by this 2. How many times? 2. You have to write the result on the rightmost side. In the multiplexer, left numbers are higher. So we started left to right. Here, right number is higher. So we always start doing the division from right to left. Okay. So this 2 will be divided by 2 times. So how many? Sir, total 3. And design is also, you can see the design is also available with this. We need 1 cross 2 demux, and then we need 1 cross 2 demux. So basically This 1 is representing 1, this 2 is representing. How many of you able to understand, beta ji? Great, sir. Now we have 1 cross 2 demux, 1 cross 2 demux. In the same way, if you observe, this 1 is going to be the input to 1 cross 2 demux. How many of you able to understand demultiplexer? Please let me know by writing in the comment section. Now the things come about the LSB and MSB pins. So we started doing the division from right to left. So rightmost two will have LSBs. Select pin, okay, and then next we'll have next significant bit MSB, and so on. It goes so on as per the division. Now why I have represented like this? Now please observe here. If we have a and I want A to be transferred here and want out this to be 0. So what select line condition we need to choose? See what select line condition we need to choose. Please observe here. Y0, Y1, in case if it is a 1 cross 4 demux, then if it is 1 cross 4 demux, then it starts from Y0, Y1, Y2, Y3, depending upon the binary condition to S0, S1, our input is transferred to the output. The same it also justify. Please observe here. I0, Y0, Y1, Y2, Y3. So this is for the Y2. It means binary of 2 in terms of S1, S0, 1, 0. 1, 0 is the binary of 2. So if S1 is 1 and S0 is 0, automatically information A is going to be transferred to the Y2 pin, Y0, Y1, Y2 pin. Is it okay? Yes, sir. Now please observe as well. Conventionally we have Y0, Y1. Conventionally top to bottom Y0, Y1. Conventionally top to bottom Y0, Y1. Now please observe, if this is 1, then A is transferred here and here we will get 0. If this is 0, irrespective of S0, both will become 0 only. However, if this is A, then for 0, information is transferred here and this will remain 0. How many of you now able to understand? Please observe Bitaji and let me know by writing the comment section. Great. Can you now calculate the number of 1 cross 4 demux required to implement 1 cross 64? Let me change to 16, okay? 1 cross 16 demultiplexer operation. Can you tell me, Bitaji, how many number of 1 cross 4 demux required to implement? How many number of 1 cross 4 demux required to implement 1 cross 16 demux operation? Okay, yes, sir. So we have to implement 1 cross 16 and we have to use 1 cross 4. So 4 times plus this 4 when divided, it will become 1. So total required will be 5. And what is the implementation? So we need 1 and then we need 4. We need 1 and then we need 1, 2, 3, 4. And can you see the circuit? Yes, sir. 1 input, 4 output. 1 cross 4 demux. Standard representation 0, 1, 2, 3. 1 input, 4 output. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So actually the circuit will become 1 to 16. Is it okay? Yes, sir. Now we have to give the specify the select line. So for 1 cross 4 we have total 2 select line. However, 1 cross 16 will have 4 select line. These 4 select line, out of this, these 4 will have same S0, S1, S0, S1, S0, S1, S0, S1, and this will be S2, S3. How many of you able to understand, Bitaji? Please let me know by writing in the comment section. How many of you able to understand? Please let me know by writing the comment section, Bitaji. Great. So all of you are well aware with the demultiplexer. So I'm giving this as a homework. all of you can easily find out how many number of demultiplexers are required. Now let's move towards the advantages of demultiplexer. If we talk about demultiplexers, demultiplexers are mostly used. Demultiplexers are mostly used in your digital communication. It is used for transmission of audio and video signals, where needs a combination, which needs a combination of multiplexer and demultiplexer. So for audio and video transmission, we use a combination of multiplexer and demultiplexer. Is it okay? These are also used as a decoders in the security system like banking sectors. Mostly decoders are used, and decoder and demultiplexers are same. Circuit wise they are same. Combination of demux with multiplexer improves the efficiency of the communication system. Is it okay? Great, sir. How many of you able to understand up to this part, beta ji? Great. Now let's have a discussion of disadvantages. So if we talk about disadvantages of demultiplexer, wastage of bandwidth might occur in digital data transmission, and delay may increases due to synchronization of the signals. So there is a possibility of delay, which again increases the chances of error in the system. Okay. If we talk about application, already I have told you about the application, so need not to write again, but I'm just keeping it in the same. Sometimes this part is important for engineering services, so I'm just removing it. You can have advantages of this demultiplexer and multiplexer, that's all. How many of you able to understand up to this part? Please let me know by writing the comment section, betaji. Great. So now we know about the demultiplexer and multiplexer. Now we know about the demultiplexer and multiplexer. So can we move towards the decoder? Before moving towards decoder, let's have a discussion little bit more about the multiplexers and demultiplexers, okay, through the questions. So please observe here. What is given in the TTL circuit shown in the TTL transistor logic circuit, where unused input will be treated as logic 1. We all know. Where unused input will be treated as logic 1. We all know. Yes, sir. So in TTL circuit shown S2 to S0, the selection lines and X7 to X0 input lines, S0, S0, X0, X0, S0 and X0 are the LSBs. It is represented twice. So S0 is the select line LSB and X0 is the input line LSB. The output Y is, you have to identify the output Y from the circuit shown below. Now please observe everyone, there is a point called enable. We all know about AND gate. In AND gate, if one input is increased in each AND gate and that is connected to enable pin, then what happened? Sir, if one input to each AND gate of multiplexer or demultiplexers are connected with the enable pin, we all know AND gate get enabled when that is logic 1. So when this enable pin is logic 1, the AND gates are enabled. Otherwise, all the AND gates of the multiplexers will remain 0. And definitely, if all the inputs of the AND gates are 0, output of the multiplexer is 0, because multiplexer is a AND or logic circuit. So here, what is the function of this enable? To activate or deactivate this chipset, basically. So if you observe here, enable, we are giving a bar before enable. What does it means? A NOT gate just before enable. Enable will work in the same way. If the NOT gate is before the enable, it means the AND gates of the multiplexers get enabled when 0 is given at the input of this enable bar. Is it okay? Yes, sir. So when this is 0, then enable is high, it means circuit get enabled. Is it okay? And if this is 1, then circuit will remain in the off state. How many of you able to understand up to this part, betaji? Great. So it can be clearly observed, that this is connected to logic level 0. So if this is connected, this is connected to logic level 0. So what does it mean? It means circuit get enabled. It means circuit get enabled. The multiplexer will have a output depending upon the input and select line. Now onto the select line, we have S0A, S1B, and what is this OR gate? And this is basically a TTL circuit. So in a TTL circuit, unused input will be treated as logic 1. 1 plus anything is 1. We will get 1 only. So onto the S2, we are getting 1. Because this is a TTL circuit. In a TTL circuit, unused input automatically treated as logic level 1. Now please observe here. There is a dot representing here. It indicates X1 is a 0. There is a dot here that represent X2 input is also 0. There is a dot here. It represent X4 is also 0. And there is a dot here represent X7 is also 0. However, logic level 1 to the inputs are X0, X3 and X5, X6. So X0, X3, X5 and X6 are logic level 1. How many of you now able to understand? Great, sir. We have to identify the output Y. How many of you able to understand the internal circuitry of the multiplexer? Sir, because of the select line action, we know about the functions available here. Please observe, beta ji. Enable is high means each of the input AND gate is enabled now. Now depending upon the select, one of the input or depending upon select input being transferred, depending upon select, one of the input is being transferred to the output. Now we have S2, S1 and S0. Please observe here. S2 is 1. S2 is 1. What does it means? If S2 is 1, what does it means? It means wherever S2 bar available, that particular AND gate will have 0 output. So from 0 to 3, we have a S2 bar only, because 0, 0, 0, 0, 0, 1, 0, 1, 0 and binary of 3 as well. So 0, 1, 1. Here up to this part, your S2 is 0. S2 is 0. Is it okay? Because we are getting S2 bar. S2 is 1, S2 bar is 0. Yes, sir. And from here to here, it is get enabled. But this is 0, so we will get 0. This is 0, so we will get 0. So now only X5 and X6 information is going to be transferred to output Y. What is X5 and X6 information? Please observe. Here we are getting binary of 5 in terms of S2, S1, S0. S2 is 1 only. So we have S1 bar S0, S2, S1 bar S0. So we are getting S2, S1 bar S0. X5 is logic level 1, or I am writing X5 plus of S2, S1, S0 bar X6. This is what we are getting. Now where S2 is 1, S1 is A, S1 is B, so we are getting B bar A, X5 is 1 plus of S2 is 1, S1 is B, A bar and 1. How many of you able to understand? So what we are getting, beta ji? We are getting B bar A plus B A bar A plus B A bar, which is nothing but B XOR A only. Because XOR gate follows associative law and commutative law. So you may write B XOR A as A XOR B. So how many of you able to understand this concept perfectly? Why I have made like this? How many of you now able to understand? Sir, any classes for mechanical? Yes, sir, beta ji. Daily basis on the same channel, classes for mechanical is also available. And already I think theory of machine is going on with your favorite subject, with your favorite sir, Vishwajit sir. Okay. So please see if someone is opting for the mechanical, that is also available. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. How many of you able to understand? Can you solve such kind of questions? Yes, sir. So can I give this question as a homework to all of you? Great. Now I am moving towards decoders. How many of you able to understand up to this part? This I am also giving you as a homework, already discussed yesterday. that how many number of 2 cross 1 multiplexer is required to implement AND gate or XOR gate. So now I'm moving towards decoders. Okay, great. One very important thing, if anyone have any confusion in the homework part, need not to worry, Bitaji, you can connect on my Telegram. I'm giving the Telegram detail once again, and I am going to share this PPT as well onto the this entire lecture notes onto the Telegram. Okay, let the board respond first. Processor, sometimes the processor get hang. Oh, please respond faster, bhai. Wait for just 1 minute, Bitaji. Sir, I am one of your student and I study electrical machine from you. Thank you, Bitaji, and hoping you have enjoyed electrical machine well. Oh my God, something very dangerous happened. Now we don't have the lecture part that is completed so far because of the board issue. No problem. We will start decoder from this part and will provide you the notes. Okay. Now please write down decoders. So have you enjoyed Thakur? Great. Now please write down decoders. Betaji, sometime it happened. And now the part, my side part is increased because now I have to retry or rewrite everything again. So, okay, no issue. I will provide you. Let's come back to the decoders. Please observe decoders. Sir, how can I start preparation as a dropout? Help me, sir, for GATE 2027, please. So, because these kind of queries are coming on regular basis, let me give you some very important details, share some very important details with everyone. Okay. So, Betaji, if you are targeting GATE, if you are targeting GATE 2027, if you are targeting GATE 2027 and your branch is double E, or that again got hanged. Just a minute. Extremely sorry for this. Great. If your branch is double E, ECE or IN. Okay. Some or less you can discuss for the CSIT as well. Please observe here, your entire gate can be categorized in major groups. So first I am telling you about these 4 groups and you can plan accordingly. Please see, the group 1 will have aptitude and maths. So these 2 papers alone will have a weightage of 28 marks, and hardly it will take 100 hours for the mathematics to study, understand and practice on the different questions, and hardly it takes 50 hours to complete your aptitude portion to understand different concept based on the aptitude. Okay, So 28 marks all of you can gain, and this is the cutoff for the electrical electronics as well as IN student. Even for CSC, nearly the cutoff around 30 marks. Okay. Then we have group 2 for EE, EC or IN if I talk. Then group 2 contains network theory, control systems, signal and digital. These are easy subject. These are easy subject and scoring subject as well. Here the marks is around 30 marks. If you combine them, all the PSUs are going to call you. Most of the PSUs are going to call you for interview, and very high chances you will get the placement in PSUs and you are get selected in IIT of your preferable branch. Is it okay? Not the first preference, but maybe you are getting third, fourth preference for doing MTech. Now come to group 3. Group 3 is a core subject group. Core subject group. If you are from EE, so this bracket is for the EE. So it contains machine, power system, power electronics, and measurement. These three will have almost 25 to 28 marks of weightage, and they will take that much of time that is taken by these 4 subjects. The hours required will be equivalent. For electronics student, the same group G3. For electronics student, this is your communication, analog and EDC. So this group number 3, for those students who are from the electronics or IN. Okay, IN will have a small portion of the machine, rest are the same. Group 4 will have EMFT, and for EE analog portion will be there. Okay, for EE analog portion will be there, and you have digital, analog and measurement. So electrical measuring instruments. Okay, so this group will carry almost 10 to 12 marks. Now please observe why I am making these groups, because if someone is trying to start their preparation now, it is recommended that must go with the group 2 first, because they will make you possible to understand rest of the things. Okay, so this is very basic group. You must have to start with group 2, and then you can move to either group 3 or group 4 depending upon your preferences. If someone is from the electronics, then EMFT, and there is a CO. Okay, so computer organization, you can keep it in the group number 4. Hoping all of you able to understand this. So those who are going to start their preparation, and if you belong from these branches, in the same way you can define for the CS and IT as well. Is it okay? So there also in the group 2 you will get digital. So this group 2 is the most important group which every student have to target first. Easy subject, easy to understand, lesser concept, but practice is needed, so you can easily do, easy to score. Less number of hours are needed, and then move to the group number 3 or group number 4 as per the preferences. Is it okay? Now how to study? When we talk about how to study, there is one very simple answer for this as well. I'm telling you same thing. So now how to start your study? If you have already prepared for 1 year, or you want to do the preparation from this year, how to start? Start with one basic subject, like you have started with digital. So start with the digital and take one either mathematics or aptitude. Okay, per day you have to take 2 subjects. Okay, so at least try to cover 4 hours in a day for the lectures, 4 to 5 hours in a day for the lectures and your notes preparation, and 1 to 2 hours for the question practice of whatever you have completed. Just follow the same. Once the 2 subjects get over, Move to the next two subjects. Move to the next two subjects. Is it okay? Utilize your weekend for the revision and numerical practice. Utilize your weekend for the numerical and revision practice. Utilize your Saturday, Sunday, and any extra time, whatever you are getting, any holiday, if there is, because of any karan. Let us suppose Janmashtami is coming. You will get a holiday from your college. So you can plan a revision or a numerical solving for the entire day. Is it okay? So if you are going in this way now, everything will be covered till the last of December, and you can easily appear with a lot of numerical practice in January as well as in half of the January and this last 15 days of the December. You can go with a multiple test series. Easily you can score a very good rank. Okay. Great. Now let's come back to the decoders once again. I am again moving back to the concept. Hoping all of you able to understand, Betaji. Now please observe your decoders once again. Very important for your digital, for all the branches, including CS, IT, ECE, IN or EE. It is a digital circuit having n number of input lines and maximum 2 to the power n output lines. You can just write in a digital, it is a digital circuit having n input lines and maximum 2 to the power n output lines. Okay, keep it in this way. It produces coded output from the coded input, mostly used for the code conversion. Okay, mostly used for the code conversion, such as binary to octal, binary to hexa, and so on. Okay. Next is binary to decimal, BCD to decimal, and so on. Next is the output of a decoder are the min terms of the input variables. Output of the decoders are the min terms of the input variables. You will able to understand just when I am going to draw the circuit. Now how to represent a decoder? Let us first understand decoder with the smallest size. Okay, let us first discuss the decoder with the smallest size. Okay. Yes, sir. So please observe. First, I am talking about 2x4 size decoder. 2x4 size means it has 2 input line and 4 output line. 2x4 decoder. There is an enable pin used in the decoder. In decoders, binary data is applied at the input, and depending upon the binary data, one of the output line will become logic 1. In decoders, binary data is applied at the input, and depending upon binary data, one of the output line will become logic 1. Very easy, sir. So, sir, you want to say, suppose if this is your input I1 and this is your input I0, we have a input Y0, Y1, Y2, Y3. Then, sir, if I am applying the binary of 0, 0, then Y0 pin will be high, rest will remain low. If we are going to apply a binary of 1, 0, 1, then Y1 pin will be high. If we are going to apply 1, 0, then Y2 pin will be high, rest all are low. So, in decoder, binary data is applied at the input, and depending upon binary data, one of the output line will become logic 1. How many of you able to understand, Betaji? Great, sir. How many of you able to understand, Betaji? Please let me know. Thank you, Betaji. Lots of love. Please convert this love into your result. Lots of love and all the best for your futures. Okay. From my side, lots of blessings. You will achieve best. Now please come back to this. Please observe everyone. If we have I0, I1 and one of the output line will become logic 1. In order to understand or in order to design any desired combinational circuit, first we need to write the truth table. Truth table is the table contains all the possibilities of inputs and outputs. So we have a enable input I0, I1, and then we have output. Outputs are Y0, Y1, Y2, Y3. Yes, sir. So here we have a enable E input pin can be represented here in terms of AB. So I'm writing AB output pin is Y3, Y2, Y1, Y0. So in case if enable is low, then this chipset is disabled. If this chipset is disabled, irrespective of the data applied to A or B, all will remain low. All will remain low. If the enable is low, it means it doesn't matter what data you are going to apply, all will remain low. If enable is high, then we have four possibility of AB. Either 0, 0, A, 0, B1, A1, B0 or A1, B1. So in case if enable pin is high and the input data to the decoder is 0, 0, then Y0 pin will become high, and at that time rest of the output pin will remain low. In the same way for binary of 1, 0, 1, Y1 pin is high, all others are 0. For this Y2 pin is high, all other are 0. For this Y3 pin is high, all other are 0. It can be clearly observed that Y1, Y0 is only high when we have A bar, B bar enable. Is it okay? Yes, sir. In the same way, if we talk about Y1, then Y1 is only high when we are getting A bar B enable. Y2 is only high when A B bar enable. And Y3 is only high for A B enable. So now we know about the logical expression, minimized logical expression of the 2x4 decoder. To implement this, we can utilize the information of output logical expression. So one can easily design A bar, B bar and AB. So one can easily design A bar, B bar and AB. We have one enable and we need 4 AND gate. 1, 2, 3, 4. So if you observe, we have A bar, B and enable. We have A bar, B bar enable, A bar, B enable, A, B bar enable, A, B enable. So how many of you able to understand this perfectly? Please let me know by writing in the comment section, beta ji. So what we are getting A bar, B bar enable, A bar, B enable, A, B bar enable and A, B enable. How many of you can observe the circuit of decoder, 2x4 decoder or 2x4 1x4 multiplex demultiplexer is absolutely same? How many of you can observe the circuit of decoder and circuit of demultiplexer is the same? Decoder and demux uses same circuit, Beta ji, please let me know by writing in the comment section. The same circuit we have observed for the 1 cross 4 demux as well. Is it okay? How many of you able to understand? Now I don't have the past part because board get restarted, na? Great. So how many of you able to understand up to this part? Please let me know by writing the comment section, beta ji. Great, sir. Please let me know by writing in the comment section, beta ji. So we have 2 cross 4 decoder now. Is it okay? Can you design a 3 cross 8 decoder? Yes, sir. We have 3 input lines. And you can please, if you observe, we have the min terms A bar B and enable. So we have a min term. In terms of AB, we have all the min terms of AB. So if we have ABC, we have all the min terms of ABC 0 to 7, and one enable is also there. And that the purpose of enable is to either activate or remain disabled all the AND gates of the decoder. Is it okay? Yes, sir. So can you design a 3 cross 8 decoder as well? Can you design a 3 cross 8 decoder as well? Yes, sir. It's very easy. Can you design a 3 cross 8 decoder? Please let me know by writing in the comment section, beta ji. Yes, sir. So if we talk about 3 cross 8 decoder, we have 3 input lines. So here I can represent I2, I1, I0. At the input I am representing A, B, C. Enable is high, and we have Y0, Y2, Y3, 1, 0, 1, 2, 3, 4, 5, 6, 7. So we have Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So depending upon the input, one of the output pin will become logic 1. So all of we can see 3 cross 8 decoder now. So what is the output we are getting? Sir, enable is multiplied to all. We all can see, and we have A, B, C. So A bar, B bar, C bar enable. A bar, B bar, C enable. If the binary of 1 appear, then Y1 pin will become logic 1. A bar, B, C bar enable. A bar, B, C enable. A, B bar, C bar enable. A, B bar, C enable. A, B, C bar enable. A, B, C enable. How many of you able to understand, beta ji? Great. So all of you can see the internal circuitry as well. Can you please take beta ji? See, whatever subjects you are studying now, you have to just study and follow one teacher only. Need not to swap the teachers again and again. It's my request to everyone. Please go with one teacher, one subject with one teacher. Okay. So whatever subjects get started, always follow that teacher from start to end. Then only you will be able to understand the subject in a one way. If you just shuffle the subject now, after 2 or 3 lectures, you just think that no, he is the best, who the other one is the best, then you will not going to learn the subject. Okay, your confusion always increases. Great. Now come back to the 3 cross 8 decoder now. Okay. How many of you able to understand 3 cross 8 decoder, beta ji? Please let me know by writing in the comment section. Now we have active high or active low decoder. 2 kinds of decoders we have. In case if enable pin is indicated like this, then that is what we call active high decoder. In case if the bubble is present at the enable pin, that will become active low decoder. It means when enable is low, then your decoder get active. Is it okay? It has nothing to do with the output bubbles. However, sometimes instead of NAND gate, we prefer to design by, instead of using AND gate, we prefer to design by NAND gate. Under such a condition, we can indicate the same decoders with each of the output indicated with a bubble. So what happened if the outputs are indicated with a bubble? Please observe here, beta ji. What happens in case if the outputs are indicated with a bubble? Please observe. Note point. If each output has a bubble in decoder. Now please observe it, beta ji. So if we have ABC, and suppose if we have a enable is high only, okay? Yes sir, and we have a bubbles presented here. Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Now what happened? It is not giving a POS, it is giving SOP only. Please observe what happened now. Actually, in the previous case of 3x8 decoder, that is also called as binary to octal decoder. So if you talk about binary to octal decoder, in this case, depending upon the input binary, one of the output pin will become logic 1. However, here, depending upon the input binary, only one of the output will become logic 0. Rest all will remain logic high only. How many of you able to understand this? Great, sir. So actually what we are getting here, A bar, B bar, C bar enable entire bar. A bar, B bar, C bar, A bar, B bar, C enable, A bar, B, C bar enable, A bar, B, C enable, A, B bar, C bar enable, A, B bar, C enable, A, B bar, A, B, C bar enable, A, B, C enable. So because of the bubble, what happened? Only one output will be logic 1. Depending upon the binary data applied, only one of the output line will become logic 1. Here, depending upon the bind data applied, only one of the output line will become logic 1. Here, depending upon the bind data applied, only one of the output line will become logic 0. Is it okay? How many of you able to understand, beta ji? Great. Let's have a discussion of one question based on the same. Find the output function from circuit shown below. Suppose if the decoder is given like this, how to solve the question based on the decoder? Please observe, beta ji. If the decoder is given like this, okay, A, B, C, where A is a MSB and C is a LSB. Then we have Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. We have 3x8 decoder and one AND gate, NAND gate we have. 0, 1, 2, 3, 4. Can you tell me, beta ji, what is the output function y? Can you tell me, beta ji, what is the output function y? Output function y is summation of m 1, 2, 4, 7, or output y is summation of pi of m 1, 2, 4, 7, or pi of m 3, 5, 6, 7, or summation of m 3, 5, 6, 7. Can you tell me, beta ji, which of the following options is indicating that output function y implemented by this circuit? All of you have remember about the bubbled OR gate. What is a NAND gate? NAND gate is same as bubbled OR gate. NAND gate is same as bubbled OR gate. Hoping all of you have remember that. If we have AB, we get A dot B bar. If we have AB, we got A bar plus B bar. By using De Morgan, we have AB bar. So NAND gate is nothing but a bubbled OR gate only. So a bubbled OR gate. Can I realize this circuit as a bubbled OR gate? So I'm using a light pen to indicate you this NAND gate. What I am looking is a bubbled OR gate. If you are able to see, this bubble and this bubble will cancel each other. This bubble and this bubble will cancel each other. This bubble and this bubble will cancel each other. This bubble and this bubble will cancel each other. So actually what happened? So we are getting y1, y2. We are getting min term of 1, min term of 2, min term of 4, and min term of 7. So we are getting 1, 2, 4, 7 only. How many of you able to understand, beta ji? Please let me know by writing in the comment section. Please let me know by writing in the comment section. See, NAND gate will treat it as a bubbled OR gate. The only condition is all the input of OR gate must be bubbled. So whenever you are observing a NAND, it is similar to bubbled OR, and when you are observing a bubble, twice of this. If this is the data, we are getting A bar, B bar, C enable whole bar, and it is again passed through the OR gate. We are just getting A bar, B bar, C enable only. So we are getting 1, 2, 4, 7. How many of you able to understand, beta ji? This kind of question are going to be asked many times in the previous year. So how many of you able to understand, beta ji? Great. Now please observe once again. So I'm just removing these all these, otherwise may create a confusion when you do the revision. Is it okay? Now please move to the next part. Can we implement a higher order decoder by using lower order decoder? Yes, sir. We can implement a higher order decoder by using lower order decoder. So please write down implementation of higher order decoder by using lower order decoder. Implementation of higher order decoder by using lower order decoder. Okay, beta ji? Yes, sir. So now please observe how to solve these type of questions. First of all, let us talk about we want to implement 2 cross 4 decoder. We want to implement 4 cross 16 decoder by using 2 cross 4 decoder. If we want to implement 4 cross 16 decoder by using 2 cross 4 decoder, then how many number of 2x4 decoders are needed. So you want to implement 4x16 decoder by using 2x4 decoder. I am keeping all the things same as we have studied in multiplexer and demultiplexer. So we want to implement 4x16 by using 2x4. Which number is higher? Right side number is higher. Okay, and then you have to observe these two as well. If they are both even, there is no issue. If both are odd, there is no issue. But in case if one is odd and one is even, there may be one inverter is needed. Is it okay? So now please observe here, we have 4 and we have 16 here. So first of all, you need to divide this 16 by this 4, it goes 4 times. Then again this 4 need to be divided by this 4, so it goes 1 time. So total will become 5. And also you know how to connect these 5 decoders to make 4x16 decoder operation from 2x4 decoder. So first we need 1 2x1, 2x4 decoder, and then we need 4 1 2 3 4. Now please observe how we are going to use it. In this case we have 2x4 decoder. So 2x4 decoder means 2 input line and 4 output line. 1 2 3 4. Each of the output line will become enabled to the next decoder. Is it okay? Yes, sir. So we have a enable pin here, which I am going to make it enabled. Now suppose if we have A, B, C, D 4, then AB is connected here, MSBs, and next CD are connected here. So how many number of inputs now? We have A, B, C, D, 4 input. And how many number of outputs now? Please observe, beta ji, this is also a 2x4 decoder. This is also a 2x4 decoder, 2x4 decoder, 2x4 decoder. So it means output will have 4 output lines, 1 2 3 4, 4 output lines, 1 2 3 4, 1 2 3 4, 1 2 3 4. Here I am representing 0 1 2 3, that indicates the output lines. Again here also I am indicating 0 1 2 3, 0 1 2, 0 1 2 3, 0 1 2 3, 0 1 2 3. Okay beta ji, please let me know by writing in the comment section, beta ji. Great. So please observe here, because enable is high, so depending upon A and B, one of the output line will become logic 1. So depending upon the binary data to A and B, one of the output line will become logic 1. That can be represented as A bar, B, A bar, B, A bar, B bar, A bar, B, A B bar, and A B. Now these becomes enable to the upcoming decoders. Is it okay? So in case if A bar B we are getting here, so A bar B B bar is because of the enable to connected to each of the output pin of decoder, this decoder, and depending upon the bind data applied to C and D, one of the output logic will become logic 1. How many of you able to understand, beta ji? Yes sir, great. So enable is this pin, and depending upon the data applied to C and D, one of the output line of this decoder will become logic 1. The same for the second. If you observe here, we have A bar B. So A bar B is multiplied to all A bar B, A bar B, A bar B, A bar B, because this is connected with the enable of the upcoming 2x4 decoder. So this decoder will get enabled depending upon the A bar B condition. If it get enabled, then depending upon C and D, one of the output line will become logic 1. How many of you able to understand, beta ji? In the same way, if you observe here, A B bar is connected with the third. So A B bar, A B bar, A B bar, A B bar. Depending upon C and D, one of the output line will become logic 1. C bar, D bar, C bar, D, C D bar, C D. How many of you able to understand beta ji? Please let me know by writing in the comment section. Great, sir. Same for the last. We have AB, 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 AB connected to each of the pin, and depending upon the bind data applied to C and D, one of the output line will become logic 1. So we have A, B, C, D, 4 input, and you can easily observe from binary min term of 0 to min term of 16 I have represented in terms of A, B, C, D. So 4 to 16 decoder we have made by using 2x4 decoder. Is it okay? Please let me know by writing in the comment section, beta ji. Are you able to understand up to this part? Is there any doubt? Is there any doubt in this? Please let me know by writing in the comment section. Can you implement any higher order decoder by using lower order decoder? Any higher order decoder by using lower order decoder? Can you answer this one? Can you answer this one? Sir, how many 3x8 line decoders with an enable inputs are needed to construct one 6 to 64 line decoders without using any additional logic gates? So we have 3 to 8 and we want to use 6 to 64. We want to implement 6 to 64 by using 3 to 8. So first of all we need 8. Yes sir. Then 8, 1. So total needed will be 9. How many of you able to understand beta ji? Great sir. Can you see the structure as well? See, for this one we have 3 A, B, C, and for these 8s we have 3 D, E, F. So total 6 inputs and total 64 outputs. How many of you can now able to understand? Please let me know by writing the comment section, beta ji. How many of you now able to understand? Please let me know by writing the comment section, beta ji. Great. Is there any doubt up to this part? Is there any doubt up to this part? Please let me know, beta ji. No, sir. Great. So now one more question. Implement 3x8 decoder by using 2x4 decoders and inverter. So how to implement a 3x8 by using 2x4? Please observe, beta ji. We have to implement 2x4 and we have to implement 3x8 by using 2x4. Is it okay? Yes sir. So we can divide this 8 by the 4. 8 divided by 4. So 2 times. This 2 can't be divided by this 4. This 2 can't be divided by this 4. Is it okay? Yes sir. So if you want to design, then what happened? Unnecessarily you are increasing the delay in the circuit. Better not to divide if it is not further divisible. Is it okay? Now we can utilize the inverters to have our desired decoder. Please observe here. Please observe here. 2x4 decoder and one inverter can implement 3x8 decoder. Sir, 2 means we have total 2x4 and 2x4, so we have total 8 outputs available. 2x4 and 2x4, so we have 8 output lines. 1, 2, 3, 4. 1, 2, 3, 4. Is it okay? We can connect MSB A with an inverter onto the enable of these 2 decoders. How many of you now able to understand? And we have BC, BC. So now A, B, C, 3 input, and total we have 8 outputs. In case if no other logic gates are allowed, then we have to use one more 2x4 decoder. And in that 2x4 decoder, we only uses A bar and A. Is it okay? One input we will just keep it connected with the ground. Accordingly, we will have a bar and A output only. We will select, we will do the enable accordingly, and then that is going to be enabled to them. Is it okay? Now please observe here. So we have Y0, Y1, Y2, Y3. This reduces the circuit delay as well as cost of the circuitry. How many of you able to understand, beta ji? Because here we all can see A bar will going to be connected with each. Depending upon B and C, one of the output line will become logic high. So B bar C, B bar C bar, B bar C, BC bar and BC. Similarly here also we are getting A. So A is enable connected to each of the input pin of AND gate. Depending upon B and C, one of the output line will become logic 1. How many of you able to understand, beta ji? Now we have a minterm from 0 to 7. Is it okay? How many of you now able to understand? Please let me know by writing in the comment section. Great, sir. Great, sir. Now please observe. One more question. If we want to implement a function f of summation of m is equals to summation of m 256, it means minterm 256, by using 3x8 decoders with inverter output. With inverter output means each of the output of decoder is have a bubbles. Okay, so implement the Boolean function by using 3x8 decoder with inverter outputs and NAND gate. NAND gate. So can you implement? Yes, sir. Can you implement? Yes, sir. Very easy, sir. We can do the implementation of 3x8 decoder. Okay. So we have 3 inputs A, B, C. Because the function is not defined in terms of A, B, C or W, X, Y. So you can consider the input as A, B, C, output Y0, Y1, Y0, Y1, Y2, Y3, Y4, Y5, Y6, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. We all know about AND gate, NAND gate. NAND gate is the same as bubbled OR gate. Is it okay? Yes, sir. So if we are going to connect enable, you can connect enable 0 as well. There is no issue. If we have a enable bar, we can put 0 onto the enable bar, so we will get 1. Is it okay? Yes, sir. Now the chipset get activated on 0 onto the enable pin because the bubble is presented here. Is it okay? This is what we call active low decoder. This is an active low decoder. Now please observe, we have A, B, C, Y0, Y1, Y2, Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Now please observe here, we have to implement 2, 4, 6, 2, 4, 2, 5, 6. So 2, 5 and 6. If we are going to pass it through the bubbled OR gate, which is nothing but a NAND gate only, our function get implemented because this bubble and this bubble will cancel the effect of each other. Yes, sir. So can I replace it with one NAND gate? Yes, sir. So the function get implemented. How many of you able to understand this concept perfectly, beta ji? Great. Now why we want to utilize the information of decoder or AND NAND gate or OR gate? whenever we are using decoder and OR gates, then we can implement any desired function. For a moment, suppose I want to implement a single circuit for half adder and half subtractor. Okay. Please observe, beta ji. Suppose we have to implement half adder and half subtractor by using decoder and basic gates. So can you design a half adder and half subtractor circuit by using decoder? Yes, sir. Half adder means we need a sum and a carry as a bar b plus ab bar, that is a XOR b, as a sum or a difference, and a borrow is ab and a borrow is a bar b and a carry is ab. So sir, we can use 2 cross 4 decoder. If we use 2 cross 4 decoder, we have all the possibilities of AB. We can utilize a enable, keep the enable high. Then because of the decoder internal circuitry which contains only AND gate, we have A bar, B bar available here, A bar, B, AB bar and AB available here. So if I am going to use one OR gate, then sum or difference of half adder, that is A XOR B, get implemented. So this circuit is much faster comparative to using one XOR gate, because here we have only AND gate and OR gate. Yes, sir. And also it's a single circuit. So we can have this as a borrow and this as a carry. So here we can implement the single circuit for implementing half adder and half subtractor. It can be implemented by using one 2 cross 4 decoder and one OR gate. So half adder and half subtractor can be implemented by using one 2 cross 4 decoder and one OR gate. How many of you able to understand up to this part? Please let me know by writing in the comment section. Can you implement a full adder and a full subtractor single circuit? Yes, sir. Let's implement full adder and full subtractor as well. So can you implement full adder and full subtractor? Yes, sir. So implement full adder and full subtractor. Full adder. Let's talk about full adder only. Implement full adder by using decoder and basic gate. So can you implement? Yes, sir. For full adder, we need A XOR B XOR C as a sum. So we need 3 cross 8 decoder. Here we have A, B, C and output as 0, 1, 2, 3, 4, 5, 6, 7. So Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. And I'm keeping the enable pin high. So we have A, B, C. So how many possibilities we have? 0 to 7. Depending upon the binary data applied to the input, one of the output line will become logic 1. We all know about the full adder. We all know about the full adder. We all know about the full adder. Hoping all of you remember the full adder. Hoping all of you remember the full adder. Basic gates, not hates. Hoping all of you remember about the full adder. Yes, sir. In a full adder, the sum is A XOR B XOR C, which can be indicated as 1, 2, 4, 7. So you can pass through the OR gate 1, 2, 4, 7. And the greatest advantage of decoder is all the min terms are available at the output of the decoder. You just pass through the OR gate, your function get implemented. If we want to implement a full adder by using 2 XOR gate, the delay is high. However, if we implement the full adder by using decoder and OR gate, the delay is comparatively very low. Is it okay? How many of you now able to understand? Great, sir. In the same way, carry, we have 3 majority bit detector circuit. That is 3, 5, 6, 7. 3, 5, 6, 7. So we have sum bit, summation of M, 1, 2, 4, 7, which is indicated as A XOR B XOR C, and carry, summation of M, 3, 5, 6, 7, that is AB plus BC plus CA. How many of you able to understand up to this part? So, one full adder can be implemented by one 3x8 decoder and one OR gate. Is it okay, beta ji? Yes, beta ji. You can have a NAND decoder as well. If you want to design a NAND decoder, there is no issue. Can you implement it by using NAND gates? Yes, sir. We can implement it by using NAND gate as well. If you want to implement by using NAND gate, then all the AND gates of the decoder are replaced by NAND gate. And if you put bubbles here, then this will become a NAND gate only. This will become a NAND gate only. So you can replace this with a NAND gate. Then also the same function get implemented. But here instead of basic, we have. How many of you able to understand? So yes, beta ji, you can use this by using basic gates, or you can use this by using NAND gates. How many of you able to understand up to this part? This is a NAND decoder. If all the bubbles are present at the output, then that will become a NAND decoder. Is it okay? How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. Great. So now we know about the NAND decoder as well. Can you tell me what is the output for the circuit shown in figure below? What is the output for the circuit shown in figure below? What is the output for the circuit shown in figure below? Can you tell me what is the output function for the circuit shown in figure below? Haji beta. Can you tell me what is the function for the circuit shown in figure below? We have a enable pin. Can you please tell me what is the function available here? Haji. Whether the function is summation of M 0, 2, 3, 6, 7, or the function is pi of M 0, 2, 3, 6, 7, or the function is 0, or the function is logic level 1. So which of the following is correct? Sir, if this is a normal circuit with the enable pin and enable is grounded. So if enable is grounded, all will become 0 only. So you will get function output 0 only. How many of you now able to understand? Please let me know by writing in the comment section, beta ji. Hoping all of you able to understand the concept of enable as well. Is it okay? Is it okay? Is it okay? How many of you able to understand up to this part? Okay. So I'm just concluding the today's topic. Hoping all of you have enjoyed well and able to understand the decoder in a well way. Tomorrow I am going to discuss about the BCD to 7 segment decoders and encoders, where we will discuss about the priority encoders as well. I am keeping the today's class as demultiplexer and decoder part only. Machine Guru sir, I am Faizan. Got moderate rank in GATE EE with a good interview, sir. I got selected in IIT Kanpur. Kharagpur or Kanpur? IIT Kharagpur in instrumentation and integrated electronics. Thanks, sir. Oh, great. Lots of love, Betaji. But rank doesn't matter because ultimately you have achieved what you want. So it means, this is a very important message for other students as well. So one student is mentioned here, paid student, okay. So student mentioned here his rank and also indicated that that interview will have a lot of weightage, okay. So if you are preparing well now, definitely you will get an opportunity. Doesn't matter sometimes that 3 hours may be against our favor, but still if you are managed somehow, you will get the opportunity to reach to your destination. Lots of love, Bitaji, and I just wish you all the best for your future, and may God makes you whatever you want. Okay, so you will achieve all success in future. Okay, love you, Lord Bitaji. Now please come back to this. Hoping all other students who are watching this able to understand that though somehow if the paper is here and there, and if you have prepared well your subjects, then you have the opportunity. Your effort never going to be waste. Always remember this. Your effort never going to be waste. Is it okay? Great, Bitaji. Great, Bitaji. Now please come back to this. Can you answer this one? Can you answer this one? So we have a Boolean function f implemented in the figure using 2 input multiplexers is. So can you answer this? Sir, we have, this is a multiplexer 2 cross 1, 2 cross 1. Okay. So if B, we are getting here B bar C bar, B XOR C, and this is at this select. This E is nothing but B XOR C only. So we will get E bar 0 AE. So actually we are getting AE, and E is nothing but B XOR C. So basically we are getting A B bar C plus of A B C bar. So 5 and 6 we are getting min term of 5 and 6. We are getting min term of 5 and 6. Hoping all of you can solve such kind of question. I am giving one question to you as a homework. This question is from the CS branch, and all of you can easily solve. In the same way you have to approach. All are the 2 cross 1 multiplexer. In the same way you can approach. So for all the homework question, please connect to the Telegram. Previously also I tried to show you that Telegram and the board got hanged. Again the board got hanged. So today's class is much affected because of this. Oh my God. Again it got hanged. Okay, no issue. Hoping you have enjoyed today's session a lot and able to understand all the topics, especially your decoder and demultiplexer. So only 4 kind of questions are possible with a decoder and demultiplexer. They will give you a circuit, or they may ask you about the select conditions for having the desired output. Is it okay? So demultiplexers or decoders can be the part of some circuit, especially decoders with a NAND gate. Mostly the questions have designed in the previous year. So now you can easily answer. Try to go with all the combinational part of your PYQs. Definitely you will be able to solve each of them. Okay, so first go through the gate questions and then move towards the your engineering services objective exam questions. Is it okay? I'm keeping the class up to this part only. Unfortunately, this got again stuck. Let's see if it indicates. Very good. Otherwise, we will keep up to this part only. So it is very difficult to get the notes today because it crashed twice in today's lecture. But we'll try to provide you. We'll try to provide you. So please get connected onto the Telegram. Please get connected onto the Telegram. Oh, there is something get. So no issue. You can find easily Varun Sir PW on Telegram. Get connected onto the Telegram for all your future updates, and we'll discuss rest of the part tomorrow. Okay. So thank you everyone. Lots of love. I'm keeping today's class up to this part only. Okay. Thank you everyone. Good night.